this problem.
This problem appeared at MathCon's Nationals several years ago. And when we tried to solve it separately, I found one answer, Mr. Funk found the other answer.
It's very interesting. We were making this video 2 days ago for our online UC3 course. We think this is a good problem involving what? Yannick, what are the common techniques could be involved in here? Some kind of
similar triangles.
Yeah, lots of similar triangles, right? So about circle, we think it's a good problem for our students to practice. So we choose this, and then we compare our answers, we realize our answers are different. When we keep challenging each other, what's wrong with it? And finally, actually, we realize the problem that is actually wrong. So this is another issue about our, the purpose of our talk is there are so many test problems, right? Many people do old problems, and then they find that, they do lots of old problems to practice for the test. I think they do lots of building work, right? Instead, they should get more out of the problem. If you go to MathCon's Nationals, you did your contest, you got your score, and you go to the countdown round, see Vijay on the stage, what do you get, top 4?
Top 8.
The top 8, right? And then you're happy, you go home, you're done. But on the other hand, some of the nice problems on the test, if you don't do them, you didn't gain enough from the contest, right? So this is why we pick some very classical ones to really help our students to digest, to realize how to improve them, based on the problems they did, but they never really digested well, okay? So this problem, our purpose is, our question is, find out a way to show why this problem is wrong. I will be the one who introduced the last 4 problems. The reason is there are some nice stories behind them. Again, this follows my comments about how to develop problems by viewing them as a group, as a sequence, and then also expanding them by asking different questions, right? This problem number 4 appeared in 2004 AD. It's a very nice problem, written by Mr. Ryder, who used to be the AMC chair during the 1995 to 2000 period. He was talking about a number who basically what? If number is small, the next number will be big, and then the next number will be smaller, right? So that's why he thinks it's like snake-like. It's like curving around, right? So it's a good example for our students to try. Okay, it's a wonderful problem. But when a few of my students back in 2004, when they took the exam, they misread it. They misread this problem into problem 6. You see, when they took the test and they came out, they feel like, wow, I got the one number. They find this problem is very, very hard. They don't know what to do because they misread the problem. AI less than AI plus 1 if I is odd, and AI less than AI if AI is odd. That's a totally different story, right? One is about their position, one is about their value, okay? The student who misread this is one of my very, very strong students, Tony Zhang. He won the IMO gold medal in 2004. So he was the one who did it wrong. And he came up, he said, actually, he had trouble solving this new version. So I was sitting there thinking with him, wow, this is a nice problem, actually, right? So later on, we worked together and solved it and wrote for it, submitted to Amy in 2007. And then they happily used it. Because the 2 problems look very similar, but they are completely different technique.
But in the first problem, we had that the digits are different.
Yes.
When we solved it, did we solve for different digits or?
Oh, in the second one, it's much more messier in that way, right? But in the first one, you do require them to have distinct digits because otherwise you have too many cases because it is a casework problem, right? I suddenly thought about this problem because actually in 2005, 1 week ago, in the Chinese math contest, their first round is equivalent to basically our AMY before their Winter Olympia camp. They have this problem 5, which is almost like an extension of problem 4. But this time they asked the question in a different way. They eliminated the condition of what? They have to be distinct. They're still asking 4-digit numbers like this, to have this property. But they ask for 2 types. One is the snake this way, one is the snake backwards. And then they ask them, what's the number of differences? You have one type of snake this way, and you have another type of snake the opposite way. And how many of those numbers are first type, and how many numbers are second type, and what's their difference, right? So that's, again, is beat up a dead horse, but somehow you produce a new horse to ask, right? And so this is all generated from number 4 by mistake or by intention that we continue to write better problems. Further interesting is this problem number 6. After I discussed with Tony, I realized if I swap these 2 around, if I swap this odd and even around, the problem becomes even harder because the first digit make a huge difference now, right? So during the same year, we wrote this problem for the Chinese national team selection, is swap these 2 conditions. And that's in problem number 7, right? So we introduced the background of these problems, our philosophy. So hopefully in the next week, you can enjoy these 7 problems and join us again next week. We will talk about another set of problems and the solution of these problems.